Hello and welcome CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course, and this evening's video tutorial is going to be on challenge activity number 7 from our final week here dealing with spanning tree, where we're going to be taking a look at the multiple spanning tree protocol one final time. So let's go ahead and dig in right now and take a look at our scenario. We have a customer who is currently running our PVST Plus, right? So they're running the Rapid Spanning Tree protocol, but they're using Cisco's Rapid per VLAN Spanning Tree Plus mode. And this is also, you'll see this sometimes as per VLAN Rapid Spanning Tree Plus, remembering that that plus sign is indicating that we're talking about 802.1q trunking encapsulation. So what do we have to do here? It looks like the administrator has configured a series of LANs, but there's going to be many more that need to be configured. So we're going to create two instances, MSTI1 and MSTI2. We're going to use the region name of switch with a revision number of 1. So it's going to be very straightforward here. Switch 1 is going to be a root bridge for MSTI 1. Switch 2 is going to be the root bridge for MSTI 2. And so we're doing a migration here, so what we're going to want to make sure that we're cognizant of is the fact that we're going to want to do this migration from the core switches outward, right? Or from the what you would say would be the distribution layer switches, but in here we're talking about the root bridges. And we're going to see what happens when we get this PVST inconsistent, where we have maybe a root bridge that is one of our leaf nodes as opposed to the actual distribution layer switches here that are going to be switch 1 and switch 2. So let's go ahead and dive into the activity here. Let's clear the screen there. Let's go ahead and dive into our activity. So you can see we've got our topology here. Quite a few switches connected together. Not clear whether or not you would see something like this in reality. You may. So let's go ahead and jump in. We're going to go from user exec to privilege exec, and I'm going to say show spanning tree root. And so let's find out right now. And you can see we've got, looks like just about 50 VLANs, or actually, what is it, from 10 to 50. So about 40 VLANs configured. VLAN 1, we are not the root bridge. 26 and 27, we're also not the root bridge. And the way that I'm making this determination is the root cost, right? So remember, the root cost, if it's 0, we're the root bridge. And you can see that we are not the root bridge for VLANs 26 to 50. However, we are for 10 to 25. So 10 to 25 were the root, 26 to 50 were not. If we come back over to our scenario, you're going to see here that 10 to 25 are going to be grouped together, and that's going to be on switch 1 will be the root bridge for MSTI1, and then 26 to 50 is going to be for MSTI2. So let's check now, because it looks like things may be coming together rather nicely here. If switch 2, we'll go from user exec to privilege exec, and we're going to say show spanning tree root. And just as you would expect, so switch 1 is the root bridge right now for VLANs 10 through 25, and switch 2 is the root bridge for VLANs 26 through 50. Let's go ahead and say show interface trunk. It looks like everything is functioning the way it's supposed to. And it looks like the trunking work has been done. The VLANs and the spanning tree forwarding state and not being pruned are 10 through 50, so everything there looks good. So let's go ahead and start our configuration. So again, we want to start from the core switches, but we're actually going to break this. I'm going to come all the way over here onto ASW3, and let's go into privilege exec. I'm going to say show spanning tree summary. So you can see that we're using rapid PVST mode. If I were to say show spanning tree root, you can clearly see that switch ASW3 is not the root bridge for anything that's going on here. So let's go ahead right now and let's break things. So we're going to come in, we're going to be a little disruptive initially because we want to see what happens if we configure things incorrectly. and we want to take a look at this inter-region problem that we're going to have where ASW3 is going to be configured again as the leaf furthest away from where the root bridges are going to be located. And so here's what we're going to do. So ASW3 is going to be configured first with MST. And this is clearly as far from the root bridges SW1 and SW2 that we can be. But this is not the root bridge. The priority is, I believe it's going to be lower on switch 1 and switch 2. We can take a look at the priority as well. But we should be able to just go ahead and configure this. And immediately what's going to happen is we're going to get inter-region communication here and here. So both of these links, right, are going to be inter-region communication because this will be the only switch configured for multiple spanning tree. And what we're going to see is, and this is one of the conditions of backward compatibility, is that you have to have the root bridge must be in the multiple spanning tree region, or else any of these root bridges on the outside that are running RPVST plus or PVST plus are going to have issues. Now remember that even if it's RPVST plus, that it will downshift to PVST plus, right? So even though we're running RPVST plus out here, it's going to treat it as if it's PVST plus, and we're going to see a PVST inconsistent error. Whoops, sorry about that. I was hoping for an I. PVST inconsistent error on these ports. And the reason we're going to get this error is because we have a region configured here, yet the root bridge for the multiple spanning tree region is not the root bridge for the VLANs that we're going to be configuring. So let's go ahead, squeegee the screen off here, and let's head back over to ASW3. So we're on ASW3 here, and let's go ahead and we're going to say spanning tree MST configuration. So we're going to go into spanning tree configuration mode for multiple spanning tree. We can abort, we can exit instance, right? So we want to make sure that we get well, actually, we'll just do it in order here. Let's get the name done first. So the name is going to be switch. The revision number, we're going to start with 1. Now let's do our instance to VLAN mapping. So instance 1 is VLANs 10 through 25. And instance 2 is going to be VLANs 26 through 50. Now, remember, this is just the multiple spanning tree configuration. We haven't actually enabled spanning tree. If I say do show spanning tree summary, what you'll see is that we are still in rapid PVST mode, right? So we have to enable multiple spanning trees. So let's make that happen, and this is where we're going to see some activity. In fact, let's go ahead and say debug spanning tree events. So let's get some output that's going to tell us a better story than what we might normally see. So in order to change the mode, I would simply say spanning tree mode, and you'll notice we only have 3 choices, right? It's either going to be PVST, rapid PVST, or MST. And that's it. So we've configured everything we need for our multiple spanning tree configuration. Now let's go ahead and flip the switch, and there you go right there. So you can see that the designated port is put into blocking state. We get the spanning tree 2 PVST IM, and let's get the pen up here. So here you go right there, and this is exactly what we would expect to see. We get a spanning tree error telling us it's blocking the port because superior PVST BPDU received on VLAN 10, and whoops, the trap jumped in there, on VLAN 10, claiming the root to be, and there is the root priority along with the MAC address. So here's the bridge identifier, and that is who is claiming to be root out Ethernet 00 and Ethernet 01, because again, we are not the root bridge. There's a lower priority on switch 1 as well as on switch 2, and so therefore we're going to get this error. So now let's see how this manifests in terms of, if I say do show span, whoops, say do show spanning tree. So, and there is the PVST inconsistent error. You can see that it's a boundary port. And remember, the boundary is actually rapid per VLAN spanning tree, but you see how we get this sort of this downshift here to per VLAN spanning tree. And so again, this is when you would see that error, when we've configured multiple spanning tree, and this is really because now remember, those links, the two links for ASW3, Ethernet 00 and Ethernet 01, those are both blocking links. So right now, that link is down and this link is down. So if I had hundreds of hosts hanging off of this access layer switch, and they're trying to, let's say, maybe the router's over here, to get out to the router. Right now, every host over here is down. And so this is, again, why it's so critical in a real live migration scenario, why you want to configure your quote-unquote distro or core switches that are going to be your root bridges, right? Root bridge here for 10 to 25, and this is going to be the root bridge for, let's say 26 to 50. But again, this is why it's so critical to begin your migration from the root bridges, the current root bridges, and work your way out to the leaves, because there's full backward compatibility. Don't get me wrong. I'm not trying to say over here that there's no backward compatibility, and this is why this broke. This broke because one of the rules with multiple spanning tree is when you create a region, because right now this switch is on an island and he thinks he is region switch. And then remember that was the SWITCH. That was the name we gave the region, was just switch. So as a multiple spanning tree region, if he is not the root bridge for the VLANs that are configured in his instance, VLAN to instance mapping, and we're trying to work with backward compatibility here with either rapid per VLAN spanning tree or per VLAN spanning tree, he will put these ports into a PVST inconsistent state and block both of those links. And that's exactly what we're seeing right now. So again, it's always good to get in there, especially in the Cisco Learning Labs. You've got a great opportunity to jump in here, make changes. Very easy to reset your configs and start again. But we definitely wanted to see that, because this is exactly why with migrations always start from the current root bridge and work your way out. So let's do that. So let's go ahead, let's jump on switch 1 here, and we're going to go from user exec to privilege exec into global config, and really the commands are pretty much going to be the same the whole way through. And remember, don't just go in and say spanning tree mode MST. We don't want to do that either. We want to define the configuration, make sure we have all of the instance to VLAN mapping work done up front with the revision number and the region name, and then turn on multiple spanning trees. So let's go ahead and say name switch. And we're going to say revision 1, and then instance 1 is going to be VLANs 10 to 25, and instance 2 is going to be VLANs 26 to 50. Now this guy's done, so we can easily say spanning tree mode MST, and we'll flip him over to spanning tree mode MST. Let's do the same thing here for switch 2. We'll go from user exec to privilege exec into global config, spanning tree MST configuration. We're going to simply say name switch, and then revision 1, and we're going to go with instance 1 VLANs 10 to 25, and then instance 2 is going to be VLANs 26 to 50. We'll exit out here, spanning tree mode MST. Now, this is the key concept here that we want to make sure we've got our root bridges set up and ready to go. So if I come back over here, you can see we get this blocking telling us that something might be failing. So if I were to say do show span, you can see that we've got a PVST inconsistent, right? We have two boundary ports, and that's just fine, but we've got this inconsistent here on Ethernet 02. So if we come over to the diagram, Ethernet 02 is running this way over to ASW1, and so we'll take a look at that here in a second. So let's next take on switch B, and we'll go into global config, and we'll say spanning tree MST configuration. Let's go ahead with name switch revision 1, instance 1, VLANs 10 to 25, and again we're simply mapping VLANs 10 through 25 to the first spanning tree instance, and now we're going to map VLANs 26 to 50 to the second VLAN instance, and then we're going to come in here and say spanning tree mode MST. And again, we could have put the configuration component on all of them and then quickly have gone through and said spanning tree mode MST, but there's no reason why we can't do it this way as well. So let's say let's save, let's go ahead and write out our config. So we'll say show span, right? And you can see we've got MST0, there's MST1, and here is MST2. We've got some edge ports. All right, so that's switch B. We've done switch 1, switch 2. Let's come over to ASW1. Go from user exec to privilege exec. We'll say spanning tree MST configuration. We're going to give it a name of switch. We're going to say revision 1, and then our instance, our VLAN to instance mapping. So instance 1 is VLAN 10 through 25, and instance 2 is going to be VLANs 26 through 50. Again, this is a great exercise with a lot of opportunity here to work with multiple spanning trees. So spanning tree mode MST, and then we're going to say end. So let's say show span. You can see now it's no longer showing VLANs, right? We're not doing per VLAN. So when I say show span, I'm seeing the multiple spanning tree instances, MST1, which is VLANs 10 through 25, and then MST2, which is VLANs 26 through 30. Now let's stop right here. Let's pause here for a second, and let's take a look at some of the output that we have here. So you can see for MST1, he says this bridge is the root. For MST2, he says this bridge is the root. And we have a single boundary port here, right, out to a PVST neighbor, but we know that these are rapid PVST neighbors. And so still a boundary port because we've got a couple more switches to configure. When we take a look at the priority, you can see the priority is 32769, or it would have been 32768 plus 1. And remember, the plus 1 is the instance number now. Remember we talked about that 802.1T, which was the system ID extension field. And remember that that was originally used for the VLAN number. It was 12 bits, and we were using that for the VLAN number. And that was with per VLAN spanning tree plus as well as rapid per VLAN spanning tree plus. Now, we're not using PVST or rPVST anymore. Now we're using multiple spanning tree. Well, we still needed that 802.1T field, that system ID extension. And what is it now? It's no longer the VLAN. Now it is the instance number. And so you can see it's the same concept, right? System ID extension is 2 because it's MST2. If I created instance 99, VLANs 10 through 25, then we would be adding 99 to the default priority of 32768, right? So, but again, you can see that this bridge thinks it's the root. So let me go ahead and clear that off there. We still have a couple switches left to get to. That was ASW1. Let's come down. So this is probably where it saw the, right here was the boundary port, because ASW2 is sort of the final switch that needs to be done. So let's go from user exec into, into privilege exec, and then let's jump into global config. We're going to say spanning tree MST configuration. Again, remember, setting up the spanning tree configuration is 100% harmless. There's absolutely nothing wrong with us doing this and it doesn't impact anything. It's not until we turn on multiple spanning tree that things start to change. So name switch revision 1, let's go ahead and say instance 1 VLANs 10 through 25, and then instance 2 is going to be VLANs 26 to 50. All right, and let's jump out of here. We're going to say spanning tree mode MST, and this is going to complete our region, right? So now we no longer have inter-region communication. So let's say show spanning tree MST. And we've got right now, it looks like a dispute, but let's see, well, actually, there's still one thing we need to do in this MST configuration. All right, good. So we've got everything mapped. So let's walk through each of these guys here. A SW1, let's go ahead and say show spanning tree MST config, and that looks good. And you can see instance 0 is always there, and that is the internal spanning tree, or the IST. And when we talk about inter-region communication, that is the instance that's communicating. The MSTI 0, or the internal spanning tree, is the instance that's communicating with other regions. So let's go ahead and say show, what are we doing here? MST configuration, or show spanning tree MST configuration. So we're good there. The one thing we forgot to do is the root bridge, the root bridge settings. So let's say spanning tree MST, and we're on switch 1 here. So let me double check the scenario. So switch 1, VLANs 10 through 25, MSTI 1. And let's make sure we've got this right here. Switch 1 is the root bridge for MSTI 1. All right. So switch 1 is going to be the root bridge for MSTI 1. So in order to do that, we say spanning tree MST and the instance number, right? Because remember, it's instance number 1 that switch 1 is going to be the root bridge for. And we're going to say root, and I'm going to actually, we're going to say, let's say priority. I'm going to set the priority to 0. I prefer setting the, like, hard coding the priority in rather than allowing spanning tree to try to drop it 2 intervals from whatever the current root bridge is. And so the secondary, on the secondary we go 4096. All right, so for instance 1, switch 1 is the primary. For instance 2, switch 1 is the secondary. Let's come over to switch 2 here, who's going to be our other. So we're going to say spanning tree MST2, priority 0, and then spanning tree MST1, priority 4096. All right, so we'll save this off here. So now let's confirm what we see. So if I were to say show spanning tree MST, you can see from the output that we have above, here we go. So for that's actually MST0. Let's come down here. Actually, I hit that too soon. So we're going to come down to, so there's MST1 and MST2, and that is the information that we're interested in. Let me, oops, didn't want to go over switch B there. There we go. So if we come up here, let's grab the pen. So again, you can see we've got multiple spanning tree instance 1 and multiple spanning tree instance 2. Those are the 2 instances we created. Here are the VLANs that are mapped, right? Now, it says the root bridge is at address AABBCC00 4A00. So remember, we're on switch 2 right now. And switch 2 is the root bridge for MSTI 2 or MST2, which is why we don't see 2 bridge IDs here. When you look up here, we do see 2 bridge IDs because switch 2 is not the root bridge for MST1. Remember that switch 1 is the root bridge, and this is the MAC address of switch 1. All right. Now remember we said that the timers, right, or that the max age timer, which is typically 20 seconds, remember we said that turns into a hop count. So remember that the max age time, this says remaining hops, 19. So the max age time has turned into a hop counter where after 20 hops, the packet will simply be dropped, or I should say the frame will be dropped because it's exceeded the remaining hops. It starts out with 20. So make sure you keep that in mind, and that's where you can see that value. How many hops do we have left to get to where we're going, and in this case, getting to the root bridge. All right, you can see that we've got the same port roles, right? Designated, root. If we had alternate, we'd have alternate, but we're on the root bridge here, so let's move to a different switch. We'll see that. The link types is shared, and that's because these are 10 megabit regular Ethernet interfaces. So let me go ahead and clear the screen here. And let's check out some of these other switches. Let's come back over here all the way over to ASW3, and let's say Show Spanning Tree MST Configuration, and then Show Spanning Tree MST, and let's take a look at MSTI1 and MSTI2, where you can clearly see that we have an additional hop, right? So it's decremented that max age timer down to 18 because it's 2 hops for ASW3 to get to the root bridge for MSTI1, who is switch 1. And we still have those same rapid spanning tree protocol port roles. Remember, it's really rapid spanning tree protocol that is running behind the scenes. So we call it multiple spanning tree because of the way we do the configuration and how we do the instance to VLAN mappings. But remember, what we're doing is we're simply mapping those VLANs to an instance of the rapid spanning tree protocol. Because remember, with rapid spanning tree protocol, again, the vanilla IEEE standard, we're not talking about the Cisco modes here, but the vanilla IEEE standard says that you have a single spanning tree instance for every single VLAN. And so really that's all multiple spanning tree is it's sort of a configuration hierarchy that we call multiple spanning tree, in which we're simply mapping a arbitrary number of VLANs off to a single instance of the rapid spanning tree protocol. And so let's go ahead and clear our screen here. All right, well, that is going to wrap things up for this tutorial and solution set here for challenge activity number 7 on multiple spanning tree. Again, we got at least, what do we have here? 2, 4, 6, 6 opportunities to configure multiple spanning tree, to set the revision, the instance name, or I should say the region name, the VLAN to instance mapping, as well as taking a look at what happens when you're setting multiple spanning tree on leaf nodes first, forcing an inter-region communication scenario to occur. And again, you saw, whoops, sorry about that. You saw just how unfortunate that would be if it did happen in your production environment, because that link blocked and that link blocked. And so if you had hosts hanging off of that access layer switch right there, you would be in big trouble. And that's what we like to call a resume generating event, or a career limiting move. So definitely avoid those. All right. So this wraps up our coverage of multiple spanning tree. We're going to be moving on now to inter-VLAN routing and DHCP for IPv4 and IPv6. Have a great weekend, and I will see you guys on Monday night.